Hi. So in this project, we will be discussing about campus placement prediction. So this is a full stack data science project which takes an input as the academic score of students, the work experience of students, and whether or not the student has done some kind of project, whether the student has done some kind of higher degree or not. Based on all these features, the machine learning algorithm tries to predict whether the student particular student will likely to get a placement in a company or not. So that is all about this campus placement prediction web app. So let's look at the workflow of this. So we will load the data into the data frames, and then we'll perform some pre-processing techniques like filling in the null values and generating new features and everything. After pre-processing steps are done, we'll try to query out some valuable insights from the data, and then after querying out the valuable insights, we'll choose the most appropriate features which are suitable for our machine learning algorithms, and then we will use hyperparameter tuning for setting up the correct parameters for our algorithm. Then we will save our machine learning algorithm in a pickle file, and then we will try to integrate that machine learning model which was saved in pickle file. We will unpickle it and integrate it with the UI which we will be making with Flask, and then we will deploy the entire web app on Microsoft Azure cloud service. So let me just show you the working demo of this, how this is working. So here, this is campus recruitment prediction. You can read, you can go through all the details which are given here, and if you're interested in downloading the dataset, I have given the link here as well. You can download from this link. It's a Kaggle link. Then there are few this is the form which we will be filling, and this will be when I hit on predict, it will predict whether the particular student, based on the details which are filled in the form, is eligible for placement or not, or how much likely will the student get placed based on the following criterion. So we'll select the gender, we'll select the specialization to be human marketing and human resource, and degree I'll take it as science and technology. Work experience, I'll take it yes, he has work experience. In SSC, let me say that I got 87% in SSC. In my high school, that is 11th and 12th, I got 87%. Degree percentage was also 87%. MBA was also 87%. Let me give all this, and then I'll hit on predict. Based on the details filled in the form, the student will be placed, and the percentage of getting placement is almost like 89 to 90%. 90% chances are there that the student will definitely get placed. Let's try and look at something where we cannot get placed. Let's say that our degree percentage is SSC percentage is 56, our high school percentage is 52, our degree percentage is 52, and our MBA percentage is 60, almost 60. Let's see that. So here we can see that based on the details filled in the form, the student must have to work hard. Till then, better luck next time. That means the student is not eligible for the placements because the criterion is not met. Basically, if you are having more than 65% in all the academic records, you are eligible for placements, and there is more chance that you will definitely get through the interview rounds if you are very strong at your core subjects. So as this student is not eligible, we are giving some kind of tips also. 20 tips to crack the campus placement interview. You can go through this, and this is all about the working demo of the simple campus predictor app. I have deployed this app on Microsoft Azure. I can if I just try to showcase, it's more than enough. Yeah, so here you can see that whenever you're trying to deploy it on Azure, you will be getting this azurewebsites.net as the URL at the end. That means this app is deployed on Microsoft Azure. So this is all about the introduction part. In the next video, we'll start with the exploratory data analysis of this. Last video we saw the working demo of this project where we entered some values and then the machine learning algorithm predicted that whether the student is eligible or not, and it also gave the probability result that about 87% chances are there that the student, based on the records which he has given, is eligible for placements, and there is 87% chance that the student will definitely get the job in that. So based on the percentages and records, we are predicting it. So let's look at the exploratory data analysis part of this. So over here, let me just rename this as a campus placement predictor, and then we'll start. Okay, so we'll import all the dependencies: pandas, numpy, seaborn, pandas for panel processing, numpy for numerical processing, seaborn and matplotlib for visualization. These are all the standard libraries which we have to follow when we are doing data science projects. Then we will read the data by using pandas.read CSV, and the data is present in this directory only, that is placement data full class.csv. So once we get the data, I will look at the info whether there are null values or not. So over here it's saying that there is no null values, and they are saying that 250 entries are there. Okay, let's now separate the categorical and numerical columns. So I'll be using cat wars. Basically this means categorical variables is equals to df.select types, include is equals to object. So when this is object, basically whenever there are categorical variables like gender, if you see gender over here, it's male, m and all. Okay, so and if you see this ssb also, ssb other central and all. So this nothing means this is categorical variable. So a categorical variable has a data type of object, you can see. That is why I just made this df.info. So I'll include all the categorical variables by this include is equals to object, and I want all the column names, so that is why dot columns. And similarly goes for numerical values. I want all kind of numerical values, let it be integer or floats. So int 32, int 64, float 32, float 64, and this will include all the values, but I'm not interested in the values, I'm interested in the column names. So that is why dot columns I have kept here. And then if I execute this, I'll get the numerical values and categorical values separately. Now let me check the null values here. So I find that there are null values in salary. There is null value in this salary column, so we'll handle that null value now. So let me just find the shape of this. So 215 is the shape. Now this function over here is nothing but plot displot, which is nothing but which will help us to see how on filling the null values with mean, median or mode, how the distribution is looking to the original column. Okay, so it will be clear in a minute. Just follow with me. So first we will draw plt.figure. We will define a figure of size 15,7. Then we will draw then we will plot a distribution plot. This plot is nothing but distribution plot which has KDE, that is kernel density estimation, and histogram. So I do not want histogram, I just want to look at KDE. So I'm saying KDE is equals to true, hist is equals to false, and then I'm giving a label to this graph as actual salary, and then the color of this graph is orange I'm giving. So if you want to look at more parameters, you can just press on shift tab, and then you can just hit on this small arrow, and then you can look at all the parameters, and you can adjust and play with these parameters according to your need. Then next, as I want two plots in a single figure, I'll be using the second plot, that is sn.displot. Now this time not with salary, I'll plot column. Okay, so df of column, KD is equals to true, hist is equals to false, label is equals to col, which is passed from this, and color is equals to black. So this is the function definition which I declared. Now most frequent. So if I want to know which is the most frequent item, which is the most frequently occurring salary value. So if I want to know that, so if I just paste this over here, if I just press shift enter, I find that 30,000 is occurring more times, but this is not actually what I wanted. So if I just create a dictionary out of it, so if I just write dict, and just press shift enter, so I get this key value pair. Still it is not not convenient for me. So what I'll do is I'll convert it into list. So before converting into list, what I have to do is I have to create them into items. So when I create them into items, and then if I create into list, I'll be getting some good result. So now over here I can see that at the first index I'm getting this 30,000, which is occurring more number of times. So what I'll do is I'll simply hit this thing. So over here I'm getting this 30,000 comma 22, the same thing which is over here. So most frequently occurring salary value is 30,000. Basically that I can use it as mode. So instead of doing this big computation, we can simply we can also do df.salary.mode. If you do df of salary.mode, you will get something like this, but you want the 30,000, not the 0. So that is why if you just press in if you just give bracket 0, you will get 30,000 directly. So instead of writing this big code, you can just simply do this. Okay, so now what we will do is, what approach we will be following is, we will be creating 3 new features that are nothing but mean, salary mean, salary median and salary mode, and then we will compare the KDE plot of salary mean and salary, salary median and salary, salary mode and salary. So we will look at, we will compare all the 3 plots, and we will see which plots are similar to each other. Okay, it will be more clear when we look at the plots. So for that, what I am doing is df of salary mean is equals to df of salary dot fill na, because this salary value is having null value, right? So df of salary dot fill na, df of salary dot mean. So basically I am filling the null values with the mean value of the salary column. That is the meaning. df of salary median is equals to df of salary dot fill na, filling the null values with the median value of the salary column. And salary mode is equals to df of salary dot fill na. I am filling the null values of the salary column with the mode of the salary column. Okay, mode is nothing but the most frequently occurring item. That is what we saw over here. The same code I copied and I pasted over here. That's it, nothing else. Fill in the missing values with the mode, fill in the missing values with median, fill in the missing values with mean. If I execute this, I'll be getting 3 new columns, that is salary, salary mean, salary median and salary mode. Right? Okay, so now I will be I'll be plotting this. So how to plot this is, as I have defined a function over here, plot dist plot. So now sal list is equals to salary mean, salary median and salary mode. So for salary in salary list, plot dist plot of sal. So I am passing this sal, that is nothing but the salary mean, salary median and salary mode. One by one I will be passing, and I will be plotting them with respect to salary. It will be clear when we look at the plots. So I'll just shift enter it. Okay, so here we have the plots. Here we have the plots. We can see that over here yes, so over here we can see one thing, we can observe one pattern, which is the black one is basically if we look at this, so we said that the color orange is for the salary and black color is for the our new feature. So black is nothing but salary mean, and this orange is nothing but the original one. So we see that mean is kind of getting fluctuated more. If you look at the median value is also kind of getting fluctuating more. If you look at mode value is little bit accurate, mode value. So basically we cannot depend itself on mode, because there are 67 null values which were present. So if we just kept 30,000 as the filling value of 67 columns, then it will heavily predict our result. So that is why it's better to go with mean, because we will do some kind of pre-processing later. So what we'll do is, with this distribution analysis, we saw that filling the salary with mean would be a good choice. So we'll be filling the salary with this mean. So once I fill the missing values with this mean, now what I'll do is I'll drop this salary mean, salary median and salary mode, which I temporarily created. So, and then I will check whether there are null values or not. So I see that there are no null values left, and my data is clean now. Okay, so in the next video we'll look at the exploratory data analysis, and we'll generate some new insights, and we'll try to figure out some new patterns also. Thank you. Hi, so in the last video we saw how we can deal with the null values over here by filling the null values with mean, median and mode, and then respectively check their data, their distributions, and then come to a conclusion that which method is gonna suit more. So we concluded that mean method is gonna suit more for us. So now let's try to calculate let's try to do some EDA on the data. So first we'll plot a count plot between status and palette status. So if I just shift enter it, so I get the status of over here that placed and not placed. So I see that there are almost 140 plus people who are placed, and 140 plus people who are 60 people who are not placed. So now what I did is I defined a function which will return the value counts of the column, and then there is one function which I wrote which is used to plot the count plot, where we can kind of at once we can see all the count plot of our categorical variables. So now if you look at this, I am using only categorical variables over here, because a count plot will make sense for categorical variables only. It makes sense for numerical variables if the numerical variables are ordinal, okay, but there is no kind of ordinality which is seen in the data, because everything over here is floating values. So our numerical values are almost floating. So that is on SSCP, and then HSCP, degree P, E-test P, MBAP, salary. These are all numerical values, and then there's no kind of ordinality present in them. They are all continuous values. So we will be plotting our count plots on our categorical variables only. So our categorical variables are these categorical variables. So we'll run a loop, and inside this loop we'll call this get count function, and we'll pass the column one by one, and then we will plot the count plot of that. So basically this is the count plot syntax, and then we will be as I want some style in my X label and Y label, so I'm giving some style thing, that is rotation, font size, font weight, and all that. You can skip this if you don't want, if you're fine with normal one. So now if I try and see, I get the count plot of this thing. So SSCB, Central, Others, and HSC. I see that HSCS, there are three things like Commerce, Science, Arts, and everything. So we can just manually check this out. It's not a big thing. So after the count plot, we will find the count. So this will give us a more relevant data. This is actually a plot so that it's easy to understand how much and what things are in majority and what things are not. In an instant we can know. But if we are really interested in getting the real details, then we should get this kind of dictionary over here. So I'm just writing get final dict, which is in which we will store the entire result. So for call and cat was, so I'm saying get final dict of call is equals to value count of call. So this value count I have defined here. This is returning a dictionary to me. That is why the result is a dictionary inside a dictionary. So if I just execute this, I'll be getting this. So gender, there are two variables that are male and female, and the count of male is 113 and count of female is 76. And SSCB, there are two categories that are Central and Others, and the respective counts of them are also shown. So you can just go through this. This dictionary is very important, and I will be using this dictionary till the end. Okay, so now this is some kind of querying we'll do now. So we'll see top science students placed, because over here I am seeing that science students are 59, and let's see how many science students are getting placed. So for that, what I'm doing is first this is double query over here. So this part of the query is the first query, and this part of the query is the second query. So basically in SQL, what we write, if we want to see how many students are placed in science department, so we write select star from table name, where degree is equals to degree is equals to science, and status is equals to placed, order by salary, as order by salary, and then limit 1. If you do like this, order by salary DESC, if you do this, then we get the result in descending order. So in the same way, in pandas, it's nothing but df of, inside this data frame, df of this thing. Now inside this data frame, I want to query this. So what is my query all about? It's saying that the degree must be equals to science and tech, and then the status of the student must be equals to placed. So this is my query. So once I get the result, this will be my entire result, and I want to sort the value. Okay, so if you just look at this, this will give me a data frame itself. Okay, so if I just execute it separately, if I just execute this separately, you'll get to know what it is. So I'm getting a data frame over here. Now I want to sort the values. Based on the salary column. So if I say sort values, by is equals to salary. If I type in by is equals to salary, now you see what happens. Now this gets sorted into ascending order, but I want it in a descending order. Okay, so I will say ascending is equals to false. So there is one parameter inside sort values, that is ascending. So I'll say ascending equals to false. Now I get my values in descending order. So you can see that 6,90,000, then 5 lakhs, then 5 lakhs, 5 lakhs 49, all this I get ascending equals to false. Then what I will do is the indices are not right, so I will say reset index dot reset index. That means it will reset the indices for me. That's not an issue. So I'll reset my indices. So now reset index. After that I don't want to see entire thing, so this basically resetted my index over here. So I basically don't want to see everything, so what I'll do is I'll just say dot head of 10. I want to just see the 10 records, top 10, or basically top 5 records. So dot head of 5. So I'll get the top 5 records of students who are from science and tech background and are placed. Okay, so the salary, maximum salary of science student is 6,90,000. So that was all about this query which was written over here, top science students placed. Then we will simply copy this, and we will simply copy this and we will paste it over here. And then instead of science and tech, I'll write commerce and management, because over here in degree I have commerce and management, I have science and tech, and I have others. So I want to see what is the maximum salary from commerce and management department. So if I just do the same thing, and if I just execute this query, so I find that the maximum salary offered is 9,40,000. So the student of commerce department has got the maximum salary of 9,40,000, and the maximum salary of science student was 6,90,000. Now next what we will see the maximum and minimum salary. So this is the simple query over here. So df of salary must be equals to maximum of df of salary, or basically means that I want both maximum and minimum, right? In one data frame I want maximum and minimum salaries. So I'm saying df of salary must be equals to maximum of salary, and df of salary must be equals to min of salary. If I just execute this, I'll get this data frame over here, which says that maximum salary over here, yes, maximum salary over here is 9,40,000. If you want, you can even do sort values so that it's more clear. Sort values, if you want, you can do sort values, and you can say by is equals to salary, and then you can say ascending is equals to false. Ascending is equals to false. If you type in this, ascending is equals to false. If you type, you will see here that maximum salary is 94,000 and minimum salary is 2 lakhs. So basically the minimum pay of every company which is coming to this XYZ college is 2 lakhs, and maximum the company is paying 9,40,000, whichever company is coming. So that is the observation of this max and min salary. Now students with salary more than the average and from science department. So basically we want to get to know how many students are having what is the average salary package of science students. So average salary package of science students, if you want to know, what we will do is we will first we will calculate the mean of this. So if we calculate the mean of this, what we will be getting, if we calculate the mean of this, we will be getting some thing like 2,88,655. So this is the average salary package. Okay, now we want students who are getting more than this average salary package from science department. Okay, so from science department we want to know what is the average salary package, students who are getting more than the average salary package. So that's what I did. So selecting the students of science and technology department, and then querying the students who are having who got the package more than average salary package. So this is all about this query, and then I'm sorting the values by salary, and yes, rest all things it's self-explanatory because the above 3 queries are doing the same kind of processing. So if we just execute this, we'll be getting like yeah, science and tech maximum package is 6,90,000, and there are almost like 17 students who got salary, whose salary is more than the average salary, that is 2,88,000. Okay, so the same thing I will do with the management also, commerce and management. So if I do with commerce and management, I see that 31 students got salary more than the average salary. Average salary of all the students of all the departments. Okay, now I think so this analysis is done with respect to salary. In the next video we will cover up more in looking at the insights, and then we will plot some good count plots, bar plots and pie charts. Till then, do practice this queries. Hi. So in the last video, we dealt through some pandas queries where we did some aggregating queries on with respect to the salary of different kind of students from the science and technology background, marketing, commerce and management background and all. Then now we will carry on with our exploratory data analysis more. So we will see maximum students placed from commerce and management. So what we will do is we'll group by the degree T with respect to status, and we will find the count of it. So basically, if I just execute this separately, what this is doing is it is grouping all the students degree wise. Okay, it is grouping all the students degree wise. So it will just give me some count. Okay, it will give me a series object. Now if I do some aggregation over here, so whenever you are performing group by, you must always perform some kind of aggregation. So aggregation in the sense finding the max, finding the min, finding the average, finding the count, finding the sum, like that. So in SQL we are having now, whenever we do group by having clause, we will be using sum, we will be using max, we will be using min. So these are all the aggregate functions which we have to use when we are using group by. Okay, so over here we are grouping the technical degree with respect to status, and we want to find the count of them. So if I just execute this, so I get the degree T, commerce and management. There are 145 students. There are 11 students of other background, and science and tech are 59. So basically you can see that this thing is similar to the value counts thing. So what is new in this? The new part is whenever we do value counts, we are not able to plot the data, but using group by we are able to plot, because we are getting a panda series object over here. So if I just do this plot kind is equals to bar, color is equals to magenta, I'll be able to plot a bar plot over here, as you can see. So basically this group by function, it will return some normal counts which we can understand, but if you want to visualize it graphically, then we can directly use this dot plot, kind is equals to bar, color is equals to magenta. If I do this, I'll get the count plot basically. Then this was all about so there are almost like 145 students from commerce and management. Science and tech there are 60 students almost, and other background there are some 11 students. Then we will do the same thing. Instead of degree T, we will be applying specialization over here. So there are two kinds of specialization, which is marketing and finance and marketing and human resource. So if I do the same thing over here, I get this. But if I want to know the exact count of it, so what I'll do is I'll copy the group by part. Well, I'll press escape A so that it shifts one cell up, and then I'll press shift enter over here. So I see that from marketing and finance there are 120 students who did some specializations, and in marketing and human resource there are 95 students who did specialization. So in total that is 215. So this was all about the group by. Now what we will do is we will look at the percentage of females, because female nowadays there is more about female education and all. Like there are too many jobs which are open for, especially for female also, right? So our main aim is to get the female count. So what we will do is, now instead of bar plot, what we will do, we will try to get the stats. So basically we'll try to get the numbers over here. So if I just try to execute this, I'll get the number over here, that is male count is 76, female count is 76 and male count is 139. Now if you want to get the percentage of it, basically 76 by 76 plus 139 into 100 if I do, I'll get the percentage of female participation around 215 members. So I want to plot a pie chart of it. So I'll use dot plot kind is equals to pi, and this auto PCT is nothing but it is responsible for giving this label inside this color. Okay, so that is what this auto PCT is used. So if I just press shift enter, I see that 35% contribution is from females and 65% contribution is from males. Okay, so so 65 plus 35 becomes 100. So 35% of his contribution is from females and 65 is from males. So that was all about females. Now we will see what was the maximum female salary. So maximum female salary, if I want, first what I need to do is I need to get the gender is equals to female. After I get that, then I have to find the max of that. Okay, so basically if I try to execute this separately, what happens is over here, if I try to execute this separately, I am saying temp is equals to df of df, gender is equals to female. So this will give me all the records of female only. So you see that I'll get all the records of female only. So there are 76 females, as it is confirmed that there are 76 females. Yes, there are 76 females. And from this I want the maximum salary. So what I am doing temp of salary is equals to max salary. So I am finding this. Okay, so if I just hit over here, yeah, so over here I can see the maximum salary for female is 6,50,000. Okay, so I want to give some kind of styling to this data frame. So for that I'm using this dot style dot background underscore gradient, and I'm giving the color map as plasma. If I execute this, you will see I'll get some colors over here. Okay, so basically it's nothing but it's just giving style to this thing, data frame, nothing more than that. Okay, yep. So next we will look at the HSC column, that is we will look at the HSC column and we will see the status of that. Okay, yeah. So if I just try to look at the head part, if I just try to look at the head part, I have this column like HSCS. So in that I have commerce, science and arts. Okay, so what I need is, my main intention over here is to find the count of these departments individually. So if I just copy this and if I just paste it over here, so I see that 113 students are from commerce, science there are 91 students, and from arts there are 111 students who are participating in the placement activity. Now I need to plot this. Now I need to know the percentage of them. So that's why I'm using dot plot. I'm saying kind is equals to pi, autopacity is equals to this value, and then figure size. I want the pie chart to be 15,7, 15 centimeters on x and 7 centimeters on y. So if I just execute this, so I'll get this pie chart where this 53% contribution is from commerce, 5% contribution is from arts because there are only 11 members there, and 42% is from science. So that was all about the exploratory data analysis part. Now we will move forward with the label encoding and handling the categorical variables in the next video. Hi. So in the last video we covered how the label encoding process is taking place internally, and we saw the dictionary get mappings, which says us that these were all the encodings which were done by default by the label encoder object internally. Now we will look into the numerical columns exploratory data analysis part. So we will look at the distribution analysis first. If the distribution is following some kind of particular distribution like Gaussian or left skewed or right skewed or Poisson distribution or some kind of distribution, then it's fine. If it's completely distorted, then we will do some transformation to it. So for that, what we need is, in order to get a visual view of our distributions, we have this stats library from the scientific Python, that is SciPy. So from import SciPy.stats as stats, I'm importing this stats library from SciPy. Then I'm defining a function that is getPlots, which will take data frame and column. This column is nothing but the this variables which this column names which I'll be passing in a loop. Then I'm defining a figure. That figure size should be 15,7, and then I'm defining a subplot to be 1,3,1. That means I want three plots over here. So this is row number 1, and in row number 1 I'm having 3 columns: column number 1, column number 2, and column number 3. So I'm plotting my first plot on column number 1. So I'm selecting this. So subplot 1,3,1 means this is 1, 1,2, this is 1, 1, 2, 3, 1. So 1, 1, 2, 3, 1. That means this part. Okay, so plt.hist, I am plotting the histogram here, color is magenta. Then plt.subplot 1 comma 3 comma 2, that is nothing but this plot. So I'm plotting the probability plot over here, stats.prob plot. This will basically help me to see whether the distribution is in normal distribution or not. And then plt.subplot 1 comma 3 comma 3, this is nothing but this plot is basically used for seeing the outliers and everything. Okay, so once I plot all this and then plt.show means it will showcase all the 3 columns. Then what I'm doing is numbers 1 comma this thing. Why 1 comma this thing? Because if I just try to write num bars over here, it will have this SL number also. But if you are observing that I already dropped this SL number, so that is why I'm saying 1 comma. So I want to skip this part, basically nothing more than that. So just I'm writing a print statement that will help me to showcase the plots, and then I'm calling the function get plots and then print this. This is basically for separating the plots. Now if I just do shift enter, so I get the plots over here. So over here I get the plots. So I think so this should, if this is 75 or so, it will make some sense. Yeah, so now over here if I see the plots, so I'm finding that this distribution is Gaussian, almost Gaussian, no problem with it. Even this is perfectly Gaussian, no problem at all, because this line is exactly straight and all the data points are following the line. This is also Gaussian, almost Gaussian. This is also following all the correct similarities. There is little bit of noise over here, but let's see whether this feature we will be using in future or not, because there's a lot of noise which is coming in this side, and you can see that the part over here and part over here, they are not matching, and over here also there is a little bit of crowd. This is also Gaussian. This is fine. This is not a problem. And salary is completely distorted, will drop this for sure. And one thing to observe logically is, if we are trying to predict whether the student will get placed or not, after the student gets placed, the salary will come, right? Before that, salary will not come, no? Is it or not? Before that, salary will not come. So if the student is getting placed, that means salary will not play a role. Definitely, because after the student gets placed, the salary package will be revealed to him and the role will be revealed to him. Yes or no? So basically that's the reason why this I will be dropping the salary column now. It is not giving any kind of insights only. Basically we just took lightly for it. Now we will just drop that, because logically it is not making any sense, right? So feature selection part. Now we will look at the feature selection part. So we'll first look at the correlated features. If there are any highly correlated features, we see that there is no kind of correlation which is happening, so it's completely fine. There's no kind of specific correlation which is happening here. We will drop the salary column as well as, of course, after as I said just now, we will drop the salary column and the status column. So before going forward, what I will do is I'll just make a copy of this, and then I will say test is equals to data of status. This is my testing data. That is nothing but my test column. That is nothing but my dependent feature, and this is nothing but my, this is the independent feature, and this is nothing but my dependent features. Okay, so I'll try this. So I separated my data into training and testing. So not training and testing, it's basically I separated the predicting. What I need to predict is this test, and what I will give as input is this train. So that is the thing. If I see the train data, I'm getting this. So how many columns over here? 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 columns. Now I won't be using those 12 columns because some columns are just useless. So for removing the columns, what I'll do is we have some feature selection techniques like extra trees classifier, mutual classification information, mutual class of information. So what I'll do is I'll import this from sklearn.ansible import extra trees classifier. So EC is equals to extra trees dot classifier. I'll fit the train and test. Once this is done, now we'll plot the series plot. EC dot feature importances, index is equals to train dot columns, and I want to see the 7 largest features, 7 features which give the most important, which are most important to me. So if I just plot this, I see these 7 features over here. Now what I'll do is I want to, here I cannot see some kind of feature percentage over here, right? So what I'll do is basically I'll try to plot a pie chart, and because of this auto PCT, I'll be able to see the contribution of features as well. So over here, if I see 23% SSCP feature is contributing, 17% HSCP feature is contributing. SSCP feature in the sense, it is nothing but state SSC percentage, class 10 percentage. HSCP means high school percentage, and degree P means your BTech degree and all those percentages. If you're doing BTech or BCom or some kind of degree, that is that a degree percentage. And MBA percentage if you did some MBA or anything like that. Okay, so that is all that. So here is the distribution of features. So I see that SSCP, HSCP and degree, the percentages are giving so much kind of insight, so we cannot leave this. And these are the most important percentages, these are the most important features. The other feature selection technique is this mutual info classif. So as this is a classification problem, I am importing this mutual info classif. If it was a regression problem, then you can just you can download mutual info, you can import mutual info regression. Okay, so mutual info regression is same as extra trees classifier only. So I am saying the same kind of function, the same kind of code I am writing from here. I am copying it and I am pasting it, and I am just pressing shift enter, nothing more than that. So I get the plots. Now again, this is not showing me any kind of results accurately. So what I'll do is I'll plot a pie chart, and if I plot a pie chart over here also, this thing is giving SSCP 24% weightage, and degree P is giving us 15% weightage over here. So this is giving more kind of weightage over here basically. Okay, so now over here what I'll do is selecting the top 10 contributing features in both cases, and then we will do intersection of the both results, so that we'll get at least top 5 contributing features. Makes sense, right? So feed call is equals to list of feed bar dot n largest of 10. So if I just copy this and if I just execute it in the above cell, it will be more clear, I think. So if I just do this, feed bar object is nothing but this pandas series object. Okay, this pandas series object is nothing but feed bar pandas series object. Okay, so feed bar dot n largest, give me the 10 largest, give me the 10 most contributing features, and dot index means their values, means their names. So SSCP, HSCP, degree P, MBA P, these are all the top 10 contributing features. Okay, the similarly I will do with what we say AX. Okay, that was also a data frame only, no? AX that was also a series object only, no? So the same thing will happen, same thing will count over here as well. So I'll just do AX dot n largest of 10 dot index. If I copy, if I paste it over here, and if I if I do shift enter, I'll get the top 10 features of this AX data frame, AX series, sorry. So this AX series is of mutual information classification, and this feed bar is about extra trees. So what I will do is I'll do the intersection of this. Okay, so in order to do the intersection of these, what I need to do, in order to do the intersection, we know that with sets we can do intersection easily. So first we need to convert this index object into list object. So first I'll do list of this. So if I do list of this, I'll get this result like this. Then conversion of list to set is very easy, type conversion. Okay, then I will do over here list of this thing. Okay, so if I do list of this and list of this, so I'm getting two separate lists. Now what I'm doing is list of set of feed call. Okay, so I'm converting this into set. Okay, I'm converting this into set of this thing. I'm converting dot, there will be some functions in sets, right, like add, clear, difference, intersection. What I need is I need intersection over here. Okay, I need intersection of what? The other thing must also be set only, no? So this is list now. So if I want to convert list to set, what I will do, I'll just type in set and then I'll paste it. I'll paste this. So if I execute this, what I'm getting this. Okay, if I convert it into list, I'll be getting a list of them, so that it is easy to access. Now you see workx, degree, HSC, HSCS. So these are all the common features. These are all the common features which both of them are giving. Okay, so if I just execute this, so I'll be getting these features. Okay, so this common calls I'll be getting, and then I'll be using this common calls over here. So basically this gender, MBA, MBAP, SSCP, degree, specialization, HSCP, degree T, work X. Okay, so these are all the columns which I'll be exploring more. So over here what I can see is am I getting the same column over here, gender. I'm missing on gender, right? So yeah, sometimes this may not give you correct results, sometimes this gives you correct results, but no worries. So we'll be using this common columns only over here. This is nothing but gender. We'll be using these columns, that is train is equals to train of gender, specialization, degree, work X, HSCP, degree, MBAP and all. So from whatever I have written here, it's self-explanatory. You can just go through this and read. So these are all the most contributing features which we got as a result. So I'll be using that and I'll rename the columns accordingly. So the columns I'm using is gender, specialization, technical degree, work experience, SSCP, high school P, degree and MBA percentage. So it makes complete sense over here, because we need the gender, we need what kind of specialization you did, like you did masters in finance or masters in human resource or something. We need your technical degree also, whether you were from whether you did engineering, whether you did management science, or whether you did commerce degree or what. And then if you are having some work experience, then we will look at the SSC percentage, your high school percentage, your degree percentage and your MBA percentage. So based on these 8 features, I think these 8 features are more than enough in order to say that whether a person can be eligible for a placement drive, or if it's eligible for a placement drive, to till what probability will he make through the placement because of his course. Okay, so I am using this. So now if I try and do the value counts of this technical degree, I get this 0 to be 145. So over here if I see 0 is nothing but commerce and management, 1 is nothing but others, and 2 is nothing but sky and tech. So that is what is given over here. So in the next video we'll look at the model building part. Hi. So in the last video we did feature selection and we came to a conclusion that these 8 we will be going with this 8 features, and these 8 features will also making sense, and our classifiers, our techniques of feature selection were also giving the same kind of results. So we'll be going with this 8 features. So now we'll be proceeding further. Now we have all our training data ready. Now it's time for model building. Like we are separating the training data and validating data, and then we will run some machine learning algorithms on them. So direct importing all the dependencies like logistic regression, decision tree, random forest, support vector classifier, randomized search CV, train test split metrics. So just import them and then do train test split. I want 80% of the data to be training and 20% to be validating. So I get 172 and 43. That's completely fine. Now DC is equals to decision tree classifier. Directly I'll go with ensemble techniques because ensemble techniques give a good result. So first we will try with ensemble techniques. If ensemble techniques are failing, then we'll go for linear techniques. Okay, linear models like support vectors, logistic regression and all. So this is basically we are plotting tree. We are plotting the decision tree with the help of this tree.plotTree function, and we are passing the decision tree object over here, that is DC, and we are saying that all the cells inside that must be filled, and then the class name must be placed and not placed, and then feature names must be train.columns. If I execute this will take a little bit time, and as the data set is less, so it will draw this tree. Now over here we see that the tree is heavy, so we'll try to run a cost complexity pruning path so that we can prune this tree. Okay, so we'll do this cost path is equals to dc.cost complexity pruning path test train comma test. And if I just try to showcase what this basically means is, what this basically is all about, what this cost path will, this cost path is nothing but a dictionary now, which will look something like this. If I just try to print it, it will look something like this over here. So CCP alpha values I get and impurities I get. So this is nothing but a dictionary, right? So if I want to get the values from this dictionary, what I will do, I will simply say CCP alpha comma impurities equals to cost path dot CCP alpha cost path dot impurities. That's it. excuse me. So now I'll be collecting a lot of decision tree classifiers. Then I will be fitting those decision tree classifiers with the CCP alpha value, which is in the CCP alpha list. So if I just see the if we just see the CCP alpha list, it will look something like this. CCP alpha, if we see that there are some values in CCP alpha, we'll be using the CCP alpha over here, and then dc.fit xtrain comma ytrain, and then model list dot append. So this dc is nothing but we are appending this decision tree. So if I just execute this, so model list will look something like this. It is nothing but a list of all decision tree objects. Over here we can see model list is nothing but a list of all decision tree objects. Now we will try to find the score of this. We will try to pass, basically we'll say clf.score xtrain comma ytrain. So for CLF in model list, so for every classifier in this modifier in the model list, we are finding the training score and testing score. That is nothing but this list comprehension is saying. That is what this list comprehension is saying, both the list comprehensions. So test score and training score. So once we get the list of training and testing, we'll plot this line chart. That is nothing but plt.plot CCP alpha train score, and this is self-explanatory. I think it's very simple to understand. So if I just press shift enter, I get some kind of juggish values over here, because there's some kind of thing which has been missed completely in this case. So if I just try to execute it once again, so I may get some different kind of tree now in this case. Yeah, so if I just try to execute this once again, and over here if I get the model list and train and test, if I do, yeah, so this gets fluctuated so many times. So it's not a big issue, because over here what is the thing is the decision tree is not that big, basically, to say. Okay, so we'll try with the CCP alpha value of 0.0195, and let's see how the decision tree will look. So yeah, this decision tree looks pretty good. It's small enough, and it will give some good results only. We'll look at the hyperparameter tuning phase now. So in hyperparameter tuning, we'll look at the hyperparameter tuning in the next phase. Hi, so in the last video we saw about the model building phase, and now we'll look at the hyperparameter tuning phase. So hyperparameters are the ones which are responsible for the proper working of the machine learning algorithm. So as I have selected few classifiers like logistic regression, random forest classifier, decision tree classifier, and support vector classifier. So if you want to get the parameters of this, simply what you can do is you can go over here and just press shift tab. So when you press shift tab and expand this widget over here, you will get all the parameters. Excuse me. So you'll be getting all the parameters over here. So you can select all the parameters, and then you can the description of the parameter has been given, and you can read about all these parameters, and you can see some examples over here also, as over here they have shown some kind of examples. So exactly the same thing I did. I just copied it as a key, and then the value over here is this thing. So in random forest classifier, the n estimators are the number, how many decision trees are gonna be used. So that is the basic thing of this, and the max depth of the tree, and the min sample split, how many samples must be there in a particular leaf, in a particular node, mean samples leaf, how many leaves are to be maintained, and then the max features, and then the CCP alpha. So these are the parameters, or these are the combination of parameters and hyperparameters. So hyperparameter in random forest is n depth, max depth, and n estimators, and CCP alpha. These are the three major hyperparameters in random forest. Moving on with logistic regression. In logistic regression, we have the C value, we have the tolerance value, we have the solver. Like we want Newton CG, liblinear saga, or LBFGS. So basically this is if you try to look at logistic regression, we have what we basically do is a simple linear regression line is getting converted to a sigmoid, is getting passed to a sigmoid function, and that sigmoid function is looking like a squiggle shape. So these all functions are all squiggle shape functions only, liblinear saga, Newton CG, and all. and they are having some tolerance values. There is some C value, there is some penalty like L1 penalty, L2 penalty, an elastic net. So L1 is nothing but ridge regression, L2 lasso regression, and L2 is ridge, and L1 is lasso, and everything like that. And then max iter, that is this thing. Then we have this decision tree classifier, which is almost similar to random forest classifier only, except we don't have this n estimators over there. Rest all things are same. Then we have the support vector classifier, where the kernel is very important. Then the max iter is there, and then the tolerance value, and then the C value. C value is nothing but our intercept value. Okay, so support vector classifier and logistic regression, these two are linear models, so that is why we get some intercept values. And random forest classifier is a bagging classifier. It's a bagging technique, which is nothing but bootstrapping and aggregating. So it internally uses decision tree classifiers, so that is why the parameters of decision tree classifier and random forest classifier are almost similar. So these are all our parameters which we will be tuning. Then moving forward, we have the scores list. This is basically used for kind of, we will be using this in order to get some in order to plot our data into a data frame, like the results, the training results. Okay, so for model model name mp and params dot items, this is nothing but a params, which is nothing but a dictionary inside a dictionary inside a dictionary, triple nested dictionaries, where the keys of this param dictionary is the model name. So that is why model name is the key, and mp is nothing but, mp is pointing to the values of this. Okay, this is the value of this key, which is also a dictionary, right? So what I'm doing is I'm iterating through this dictionary, and I'm initiating a classifier object of randomized search CV. Randomized search CV is basically, and cross validation is basically a hyperparameter tuning technique. We have grid search CV also, but grid search CV takes a little bit time. Randomized search CV doesn't take that much time. So mp of model, that is nothing but the model name. So over here, what is the model name? Model name is random forest classifier, so that is why mp of model, and param distributions is equals to mp of params. What are the parameters which we are tuning, or which we are looking for? This is the param dict. So mp of params. Okay, so mp is nothing but pointing to this value, mp is nothing but pointing to this, so mp is nothing but pointing to this thing. Okay, so in that, mp of model is nothing but the random forest classifier, which is our classifier, and the parameters are this. Okay, so that is what has been passed, mp of params, and cv is equals to 5 means cross validating 5 times, n iter is equals to 10 means there are 10 iterations which are to be made, n jobs is equals to -1 means we are using all the cores of our cpu, and then scoring metric, and then the metric of cross validation must be accuracy. So based on accuracy, you are doing the cross validation. That is the meaning of scoring. So how many iterations will this work? 5 into 10 is 50, and there are how many classifiers which I define? 1, 2, 3, 4. So there are 4 classifiers. So 50 into 4, 200. So this entire code will execute 200 times. This loop will execute 200 times. But as the data set is little less, that is extend and ytran are less. If you see the extend and ytran shape, they are almost like 172 only. So it will not take much time. So if I just try to execute this will execute, and in the scores I'm appending the name of the model. Then I'm finding the best score. What is the best score that among all the cross validations, what was the best score given by the particular classifier, and then the best estimator. So this is what I am looking for. And then if I just try and look at some this will take some time, because there are 10 into 5 50, 50 into 4 200. So this will run 200 times, and then as the size of that was less, so it will not take that, it didn't took that much time. So over here we got some little bit of error, but that's fine with respect to support vectors. Now over here I'm as this scores list is nothing but inside a dictionary, so I'm making a data frame out of it. So if I see over here I'm seeing the scores. Random forest has given me 86 as the best score, and then decision tree, and then this all is been done. So if I just try and look at the random forest classifier object, and I get this kind of things. So over here you can see that this random forest classifier, if I just select this random forest classifier from here, this is another variant of random forest. Over here I see that the random forest classifier gave me 86% accuracy. So if I just select this random forest classifier randomly, and if I do the same thing, let's say that rf1 is equals to this, and then I'll do the same kind of thing. If it's giving more accuracy, better accuracy, then I'll be selecting that as my final model. Okay, so rf1.fit and then rf1.predict and then metrics.accuracy score, y test and y predict. So if I execute this, I see that it is giving 81% only, but if I try to execute with this, yeah, it is yes, it is giving me some 81% accuracy with this also. Okay, so random forest classifier, if I just simply use random forest classifier, previously I was getting some 90% accuracy on this, but then because of some changes this happened dramatically. So if I just simply use random forest, I think I'll get good score now. Xtrain, ytrain, and then ypred is equals to metrics.accuracy score. Yeah, so if I use simply random forest, I'm getting 86%, because the n estimators or max depth is not getting some kind of related. If I use max depth is equals to 5, I'm getting 83%. Let me use max depth as 10, I'm getting 88%. You see how simply by tweaking the values of CCP alpha and everything, I'm getting some good results. If I get 0.195, I'm getting 65%. This is bad. Max depth 10 is giving me 80%. If I say max depth plus 15, it is giving me 88. It's still at 88 only. Okay, let me keep it as 12. Now it's giving me 90% now. If I keep 13, that means I'm going towards convergence now. So max depth 12 was good. Now if I take n estimators parameter over here, that is n estimators parameter, n estimators, if I keep n estimators as 100, it is giving 80, it is giving this much. If I take n estimators to be let's say 500, it is giving 88% only. If I just use normally max depth is equals to 12, it gave this. So time and again it is giving some fluctuating results. So that is why we have to use cross validation over it, so that we can get some good result. On an average, this will sometimes this will give 90%, sometimes this is giving 86%, sometimes this is giving 85%. So if this is giving in range above 85, that means it is good. Okay, so that's not a problem at all. So if I use n estimators to be 267, over here I'm getting 90% accuracy. See, so I'll be using this random forest model now. If I try and look at the logistic regression is giving me 86% accuracy. Decision tree model, if I look, decision tree model is giving me 67% accuracy because of the CCP alpha value, which is wrongly written. So if CCP alpha value is this, basically CCP alpha value over here is not correctly written over here because of the cross validation. Normally if I use this decision tree, it's giving me 62. So some kind of error which is occurring in decision tree, because in random forest it's giving me 90%, whereas in decision tree is giving this much. Maybe because of some CCP alpha value which was wrongly written. So anyways, we will be using this random forest random forest classifier object only. So if you just try to execute these cells, so we will be getting everything. If I just try to see the metrics, so if I see the metrics, I'm getting some 1% metrics. Recall score is this much. If I try to plot the what we say, the heat map, I'll get this heat map. Now this was all about the model hyperparameter tuning and model evaluation. Now we'll test the model. So what we'll do is we'll create a numpy array of the training data. So training data is a pandas data frame, right? So we'll create a numpy array of this, and then we'll pass this numpy array to this random forest object. So random forest object has two methods, like predict, rf.predict and rf.predict proba. So we'll be using both of them. Predict proba will give us the probability and predict will give us the class. Okay, so so what I'm doing is I'm converting the trained data frame into numpy array, and then predicted is equals to empty list for I in range len of trained data rf.predict. So I have to give a 2-dimensional list as an input to this random forest object, which is using this predict function. Then only the prediction will be made. If I just execute this, so this will take a little bit time because training data set was 175 rows. So it classified some, so it gave me some results. Now what I'll do is I'll do train is equals to result df is equals to train.copy, result df of actual is equals to np.array test. So our test is nothing but the actual labels, and predicted is the labels which the random forest object predicted. Okay, so both them I'm converting into numpy arrays, and then I'm storing into pandas data frames. So if I see over here, I'm getting this kind of thing. Now if I just look at the value counts, the actual value counts were 148 were yes and 67 were no, and predicted were 152 were yes and 63 were no. That means 4 were wrongly predicted here and 4 were wrongly predicted here. So this is giving a good result actually. Okay, so there were 4 misclassifications in this and there were 4 misclassifications in this. Rest also totally 8 misclassifications were done in total, but overall the result was good. So this was the get mappings. So I will be using this get mappings when we are integrating it with the UI. So now I will calculate the predicted probability. As I said that we have this 2 methods like rf.predict and rf.predictproba. So here I will be using, instead of rf.predict, I will be using rf.predictproba. Nothing that I want to give the probability measure also till what is the percentage probability that the student will get a placement, guarantee placement, about 80% sure or 90% sure, 95% sure, like that. So that is nothing but the predicted probability. So if I execute this, it will take little bit time because training data set is 175 rows. So yeah, so we can see that 0.5568, 0.44940 and 1. So we are getting some kind of values over here, right? So if you just try to expand that, so you will get some thing. So predicted is this whole big chunk of multi-dimensional list. So predicted of 0 will give you this array object. So I want the first, if I want to access the first one, this is nothing but class 0. 44% chance is there that you will not get placement, 55% chance is there that you will get placement. Okay, so predicted of 0 will give you this 0.494 and 01 will give you 55 and this thing. So I'll just execute this, so you will get this, and then I'll make 2 columns separately, like prob of not getting placed, prob of getting placed. If I execute this, I'll get here the thing. Okay, so there is chance that 55% you will get placed, 44% is chance that you will not get placed. When you are having this kind of scores, 1% like you will get placement 100%, that is guarantee, and no placement 0%, like that. So I'll save the model over here. So over here I'll save the model. This is by using the pickle file, and conclusions were 68 records were misclassified, not 16. 8 records were misclassified with an accuracy of 93%, and that's it. So in the next video we'll look at the UI building of this whole project. Thank you. Hi, so in the last video we saw we ended up by saving our campus placement model, and then we completed the model testing part, and now we will head forward in making the web application. So as discussed in the starting that we will be using Flask web framework of Python. So in order to get readily started with Flask, what you need to do is just hit on Flask starter template, just copy the starter template of this Flask. From here you just copy this, and then over here you just paste it, and then we'll start with the thing. So from Flask, import Flask request and render template. So these are the 3 methods which are present in this Flask library, and then import the pickle because we have to unpickle this one. So unpickling the model, so file is equals to open of this. So in this over here we wrote it in write binary mode, now we want to read that in binary mode, so read binary, then load the file using pickle.load, and then close the file. Once that is done, then we have to in Flask we have to define routes. So over here the route is /route. This means that it is the home page. So this route is basically taking 2 methods, get and post. By default it will take get, but if you want to specify some post request, so you have to specify post also. So what is this get and post is basically get and post are basically the 2 HTTP codes or the 2 HTTP methods, 2 HTTP methods which will allow us to kind of communicate with the templates in the backend. So we have some get request and some post request. So in get request and post request, what will happen is if you want to share the data, we'll use post request. If you just want to get the status code, we'll use get request. Okay, so let's say that there is some URL over here, some URL is there, HTTPS some URL. Okay, HTTP some URL is there, and then over here at the last we are specifying /about. So we are hitting a get request that we want the about page of the entire website. So that is nothing but the get request. Now in the same way, if we want to access the contact page of the website, so we will say https some https and then the website name. Once this is done, then we will hit contact. So now what will happen is, in contact page we will there is a forum where we can post our queries of the software, like we didn't like the software, there are some issues on it and all that. So what happens is, in that case, there is some form. Let's say that there is some form over here. Okay, there is some form over here. There is some form which is present in the contact page, which says that enter your name, enter your email address, and enter your query. So this is all about the form which contains. So you manually type in the queries, and when you hit over here, there will be one button. When you hit this enter button, so what will happen is, if you see the URL for 1 second, the URL will look something like this: https / some page, some URL / contact. And after this contact, you know what will happen? After this contact, you will get a question mark, and then whatever there is, for example, name is equals to this so and so name. Okay, then, and let's say that so second field was email is equals to this, and so on. So this thing after question mark, whatever is there, the data which is there in this URL is basically because of this post request, because this form is handled with the help of the post request. Okay, so the details which we filled in this the details which we filled in this form, when I hit this enter button, it is sending the data to the backend. So from the backend we can send the data to the database. So basically, if we want to send the data from UI to backend, we use post requests. There are various other requests like put request, delete request, patch request, and many more. Those are all web development or web programming. That comes under web programming. So for now, you just understand that we'll be using two kind of requests frequently in Flask apps, that is get request and post request. So over here in our route, this route is basically taking two requests, that is get request and post request. So what is this basically route is telling is, basically this route is saying, after this / whatever the function is there, no, I'll be handling that functioning. So this route is basically meant for that only. So after this, so what I said is, this contact name, email and all, we are getting this data from the UI, right? So we have to do some kind of action with this data. If we are getting the data from UI, definitely we'll do some action with that. So that is why we are using the backend, right? So that is why after this / whatever is the thing which is written over here, in order to do that action in Flask, we define routes. Okay, so that is the main aim of defining a route. So this route is taking two methods, that is get method and post method. So under that route, there is one function which is doing some kind of processing of the data. So what is that function doing? Let's see. Okay, so this function hello world, what this function is doing is, it's saying if request method is post, then you get all this dictionary. Okay, so from where are we getting this values? So as I said that we'll be getting the values from a form. So where is this form? So this form must be in a template. So the template is over here. Now how to create the template, we'll see in the next video. Till now you just go through all the HTTP code formats like get request, post request and all. You can just see get, put, post, put, delete and patch. This is the starting of system design. If you are very much interested into system design, then you must know all this very in depth actually. Okay, but for now, for Flask apps, you just remember that there are two kind of requests which we'll be mostly using, that is get and post. So in the next video, so in the last video we covered two kind of requests, that are get request and post requests, and I said that we'll be making our templates. So in what I'll be using is, I want to make this template as quick as possible. So what I'll be doing is, I'll be using a framework known as Bootstrap. Okay, so if you just type in getbootstrap.com, you'll get this Bootstrap. So what you need to do is, over here what I'll do is, I'll quickly copy the starter template. So I'll just hit on copy. So you can make a website within 5 minutes if you are very much comfortable with Bootstrap. So I'll make a dummy file in order to showcase you. So if I just click dummy.html, So this template I'll make, and in this template what I'll do is I'll paste the bootstrap code, I'll format it. So over here I'm getting the bootstrap code, right? So now what I need is if I just hit on go live, this is nothing but the live server. If you're not having live server, you can go and install that extension from this extension box, and over here you can just write live server. Okay, you can just write live server and you can install the extension live server extension from this. So what I'm doing is over here I have written this hello world. I will remove this hello world, and I want to place some kind of alerts over here. Okay, so if I want to search for alert, just write in alert over here. Just go for alerts, and over here I am having this alert. This is very pretty alert, so I'll just copy this alert, and then over here in this dummy, what I'll do is instead of this Django HTML, I'll change it to normal HTML so that it's flexible enough for me. So over here what I'll do is dot container. This is one bootstrap class. If I just type dot container over here, I'll get the class, and then I will paste the alert over here, and I'll save it, and just I'll click on this go live. So when I click on this go live, as you can see over here, I'm getting this bootstrap template rendered in within 2 minutes. Not even 2, it didn't took even 1 minute for me to type any kind of code. It's just simply copy and paste from bootstrap. That's it. So when you're doing some data science projects, then don't waste a lot of time in UI design and everything, because spend time in doing model building and everything, because that is more important as that is more than important in comparison to web UI. So you get this alert, right? So now in order to get some in order to get a form, what I did is so in order to get a form, what I did is just go to bootstrap.com. over here you can just type in forms. And then in the forms you'll be getting some kind of various kind of forms. Which kind of form you want to choose, you can choose those kind of forms. So I am looking for a form which has select inputs and everything of that kind. So basically I get a form over here, so I'll copy this form. I'll go to this dummy.html, and then over here what I'll do is I'll make another container object so that I can give some space container, and then over here I'll give some space. M/4 is nothing but I'm giving 4 spaces of margin, and then I'm pasting over here. This is my form. So if I just look at this, this is automatically saved, and if I just look at the live server preview of it, what I can see the form over here. So let's say that I want to give some kind of label over here, so I'll just give a h3 tag. I'll say this is a form, this is a form. Okay, this is a form. So if I want to give some kind of style over here, I can say that class is equals to text center. So text center class will basically text center this h3 line. Okay, h3 heading. So basically this is a form, I get it, and over here I can fill in the email address and all and everything. Now the most important thing is, in this form over here you have to mention 2 methods, that is action. One is action, where this action is gonna head to. As over here I said that in this contact, this form is in contact page, right? So whenever you're filling the form and whenever you're hitting the submit, this data from this form is going to some route. That route is nothing but this contact route. So that is why you have to specify the path from the UI to the backend, right? So that is specified by this action. So action is nothing but this slash. That means I want to send the data whichever the user is filling in this form to the slash route, the route which has slash as the endpoint. So which route has slash as the endpoint? This route has slash as the endpoint. Okay, so action is equals to this, and what kind of method am I using? Post method I am using. So method is equals to post. Make sure that you write it in form of caps, only then it is important. And one more important thing is, whenever you are writing this forms, right, over here, whatever you are writing, you have to make sure that you are giving another name, that is nothing but a name feature. So based on this name feature only the data is being tracked. Okay, name is equals to, let's say, email. So based on this name feature only the data is being tracked. So make sure that in every form, in every division of the form, you are mentioning this name feature. So in this way you can simply create a simple standing bootstrap template within 2 minutes or 3 minutes. If you are very good at bootstrap, then it will not take hardly 2 minutes also. It's just simple copy paste. Okay, so if you look at the form of our original project. So over here the form is over here, as I said, that if I look at the notebook, you will be more familiar with the notebook. So in here, over here, we can see that there are 1 2 3 4 5 6 7 wait a minute, just let me just scroll down fast, and then over here we have gender, specialization, technical degree, work experience, SSC percentage, high school degree, and MBA percentage. So over here, gender. So gender is what? Gender is actually a select box, because there are two values of gender, right? One is the there are two values of gender, right? One is male and one is female. So that is why I am giving a select box that is male and female as an option. So select box will look something like this. Over here, if you just see, a select box will look something like this. So when someone clicks on male, the value of that is nothing but 1. When someone clicks on female, the value of that is nothing but 0. So that is what is mentioned over here, right? Male is 0 and female is 1. Sorry, female is 0 and male is 1. Got it? So in the same way, we'll be encoding this, and specialization also we'll be doing in the same way. Specialization, we are having two fields, that is specialization marketing and finance and marketing and HR. Marketing and finance is 0, marketing and finance is 1. So marketing and finance is 0 and marketing and finance is 1. This is also a select box. Okay, so this is what you can do is simply you can copy this. You can do simply Control D. If you do Control D, this will duplicate it, and then you can simply change the values. That's it, nothing more than that. You have to be very quick at this. So this is the specialization part. Once the specialization part is done, then we have the technical degree. That is then we have the technical degree. So technical degree has 3 parts, that is commerce and management, others, and science and tech. So that is why there are 3 options which are available over here. So that is also a select box. So that once that is done, then we will go and see the next part, that is nothing but work experience, whether the particular candidate has done some kind of internships or has worked at some company, XYZ company or not. That is also a select box. So that again, this is also a select box. And then we have SSC percentage. SSC percentage is not a select box. SSC percentage is all about a numeric text. So that is why this is a simple div. Input is equals to text, class is equals to form. The most important thing, if you notice that I am always specifying the name attribute over here. Name attribute, ID attribute, and name ID, name, and for. These 3 must be same. Over here also you can see work, work, work. And over here also you can see tech, tech, and tech. So basically when you're using a post request, the data will be transferred from the UI to the backend with the help of this name attribute only. So that is why this name attribute is very important. Once that is done, similar to SSC, we'll type in this high school command, and then we'll type in the degree, and then we'll type in the MBA percentage. Once all our input formats are done, then we will simply create a button. So that button is nothing but the predict button. Whenever the user will hit the predict button, that the post request will be activated, and the results would be and the result from the URL will be fetched to the backend. Okay, so this was all about the templates, how to make the templates and everything. In the next video, we'll look at the unpickling of the random forest classifier and how we can integrate and how we can display the results on our templates. Thank you. Hi. So in the last video we saw how we can design our templates. Now in this video we'll look at the unpickling of our model, and then how the data from the post request can be made. How the data from the post request can be seen, and how the data from the post request can be sent to a random forest classifier model, and then how the predictions can be made. Okay. So first we have to unpickle our model. So for that we will first we have to make sure that our pickle file is present in the same directory as our templates as our main project directory is. Then we'll load the model. That's it. Then, as I said, all about the route, that this is a place from where from where the post data will come, and then we'll do some kind of pre-processing over here. So this hello world function is defined under this route. That means this function is responsible for doing some kind of processing to the data which is coming from the form. So if the request.method is post, that means if some data has been transferred from that form. So what you do is mydict is equals to request.form. So if you just try to print mydict, you'll get more idea how the data has been transformed from there to there. So over here if I just see, I'm just selecting these things randomly. I'm saying 67, 91, 58 and let's say 58. So if I just hit predict, basically if I just look at this over here, so over here you can see that this immutable dict I'll get something like this. Okay, so yeah, basically I'll be getting the dictionary format. I'll be getting in the dictionary format. So what I need is as I said in the last video, that based on this name feature, the entire thing is made. Okay, so my dict of gender. Okay, so what was the name over here? Gender. So my dict of gender, then my dict of spec was the name for the next one. That is nothing but name is nothing but spec. So that is why I was telling again and again that name feature is very important, because we can extract the data from using that name feature only. So based on the name features or everything, I'll extract all the data. Then as I said that in the last, as I discussed in the building phase, that we are sending a two-dimensional data to our random forest object. As you can see, this is a two-dimensional data over here. So we have to pass the two-dimensional data only. So that is why this 2D list is there. So now predicting the class either 0 or 1. So normal predict function will predict either the class is 0 or 1. So that I'll store the result in predicted class. Then predicting the probability, as I said, that to what percentage will the student get placed and all. So that is what we can see over here in this over here. If I just type in over here, just if I type in some random values, if I just hit on predict, so it is saying that 62.27% is the predicted probability that the student can get the placement. Okay, so that is all about the predicted proba. Now you have to be very, very careful over here, because from here the main logic part comes. So now over here, if you try and predict, you can see that so I was talking about this dictionary only, which was being discussed. So if I want to access the key, if I want to access the values, I am accessing with the help of this name feature, as you can see from here. Then over here, what I need is predicted class comma predicted prob of 0 0. So predicted class is 1 and predicted probability is 0.37 something, predicted 0 0. So basically predicted of 0 0 is nothing but the probability of not getting placement. So over here, what is the thing is percentage of getting placement is 62.27%. That means 62% chance is there that he or she will get a placement, and the remaining 100 minus 62, that is nothing but almost like 38 is the percentage that you will not get a placement. He or she will not get a placement. So predicted prob of 0 0 will say the probability of not getting placement, and predicted prob of 0 1 will say probability of getting placement. So anyways, if the class is 1, okay, if the predicted class is 1, that means the person will definitely get a placement. That means predicted probability of getting placement is more than predicted probability of not getting placement. So that is the simple logic over here. So if the predicted class is 1, that means definitely that person has predicted probability more than predicted probability of not getting placement. Okay, so if predicted class of 0 is 1, that means the person will definitely get placement. So what is the count of that? What is the score of that? Just store it into this prob variable. Else the person will not get placed. So it's not useful to store it actually. Just simply I wrote it. You can just skip this also. That's not a problem. Then simple, you can script this print statement also. I just wanted to know how much probability is coming and what is the class and what is the probability. Over here you can see that the probability is 1, and over here you can see that the class is 1 and probability and the percentage that the student will get a placement is 63%. So over here also you can see the same result. That's it. Just in order to know whether this is printing or not. Then in order to do some fancy stuff, I am using this place map, that is 1. If predicted class is 1, then the key to it is will be placed. If the predicted class is 0, that means better luck next time, you try harder next time. Okay, then predicted class end is equals to place map of this thing, is just getting this value, nothing else. And then if predicted class is 1, then you have to render the show template. Then this show template only will be displaying all our results. Okay, render template show.html, and we are passing two things, that is predicted class end, and then predicted prob is equals to round of proba star 100 comma 2. So I'm basically, this is nothing but 0.6, this will be 0.622 something in very long decimal thing. So I'm truncating into, I'm rounding that figure into 2 decimal places, and then I'm calculating the percentage. So for calculating percentage, I'm multiplying it with 100, and then this variable is very important, placed is equals to true. I'll say why this is important just a while. So yeah, if the student is getting placed, then this template, then this if block will get executed. If the student is not getting placed, then this block will be executed. So once this is done, so the data from the backend is now going to the UI. So how to retrieve with the UI is simply a show.html. As you can see that the data is being sent to this template, that is show.html. So in show.html, this the simple bootstrap copy and paste. Now over here, this is very important. This is nothing but the Jinja syntax. So if you look at the Jinja syntax of Flask, you'll get you'll get more understanding. Jinja syntax of Flask. If you just look at the Jinja syntax of Flask, basically you can run for loops, you can run if conditionals, you can run so many things with this Jinja in Flask. So we'll be using the same kind. So over here what I did is, if the student is getting placed, right, so I'm sending a variable named as placed is equals to true. So this placed is equals to true is coming over here. Now if placed is true, then this if block will execute it. So if block, what is there in this if block? So in this if block, there is one alert, this alert, and in that alert I'm saying that the predicted result will be something. So if I just see this predicted result over here, predicted result, and then based on the details filled in the form, the student, based on the details filled in the form, the student, based on the details filled in the form, the student, colon, after that will be placed. So from where this will be placed is coming is basically from here. We are sending predicted class end is equals to predicted class end, no. So this predicted class end is nothing but will be placed. Why will be placed? Because the predicted class is 1. Over here you can see that place map of predicted class of 1 is nothing but it is giving this value, and that value as a string I'm passing here, and that string I'm extracting here in this format. So will be placed over here, right? Now after that what I do is, I want to show the percentage of that also. So percentage of getting the placement is, I'm defining a span tag so that I can show it in a different color. So I'm selecting the color to be salmon, and then predicted prob. So from where this predicted prob is coming, from this it is coming. Predicted prob is equal to round proba star 100 comma 2. So from this route, the predicted proba is going to the show.html and it is getting rendered here. This is all about this. Then some kind of to make some UI look good, I'm writing some kind of lines over here, congratulations, this that and all. So if the student is getting placement, that is, if this predicted class of 0 is 1, that means if our algorithm is classifying that the student will get placed, only then this will get executed, only then this if placed will get executed. If not, what will happen? This else part will get executed. So in this else part, what I did is, else part I just need to show that okay, you are not eligible, okay, you will not get the placement. That is what is shown. But over here, additionally, in order to look good, in order to get some tips, in order to give some tips in the UI, I have just copied this, I have just formatted this thing. Basically I have just browsed in on Google and I got some 20 tips, and then I just copied that template and I did it. So if I show you how I did that, is basically 20 opportunities, tips for selecting, just a minute, tips for getting placed in a good company. There were 20, there were top 20. So if I just look at the top 20 tips, top 20 tips for successful interviews. If I just go 20 tips for good interviews, I think so this is the page. No, this is not the page exactly. So basically what I need to do is, it's just simple. Yeah, it's just simple. What I need to do is just go and inspect and then copy this whole thing. So basically you hover your cursor over here. So once you get the cursor, once you select the main div, which is which is storing all the information, yeah, this div is storing all the information. What you do is you just hit on edit as HTML, you just Control A, Control C, and then just simply paste it in this template over here. If I just place it in this dummy template, what will happen? Let's see. So in this dummy template, if I just paste that, if I just paste this dummy template over here, and if I just look at the dummy.html part, so over here dummy.html part, if I look, so yeah, I'm getting all this kind of data over here, right? So in this way you can simply, from some XYZ website, you can just Google it and then inspect it. In this way you can copy the HTML code and integrate in your HTML files as well. So that is nothing but it's self-explanatory. So if the student doesn't get placed, then this else part will execute, and then the endif part to end the Jinja syntax. So yes, this was all about the templating and how to send the data from the backend, that is from the Python script to the UI, and how to integrate the Jinja syntax and everything. So in the next video we'll look at the deployment phase of this. We'll be deploying this Flask app on on Azure cloud. So till then, do practice and learn this Jinja syntax format, and yes, till then do practice this. Thank you. So in the last video we said that we would be deploying our campus placement predictor app. So we would be deploying on Microsoft Azure cloud platform. So before that, let's see whether how it is working on local system. So if I just sit in some random values and hit on predict, it will say me that you will get placed based on the following results, and the predicted probability is like 74% true. If I enter some data which is like it will not support me to get placed. So it was saying that based on the details filled, you are not eligible for the placement, and here are some tips you can follow so that next time when you sit on placement drive, you'll get placed surely. So this is the local this is hosted on the local host. So now we will try to host it on Microsoft Azure. So for that, what we need to do is I already have this readme file which has some kind of code which we will be using, and if you are new to Microsoft Azure, then just click on Microsoft Azure, sign into Microsoft Azure, and over here enter your email address and every detail you just enter, and keep hitting on next. There will be an email verification link, and then you should verify your email. Post verification, you'll get a portal where you have to pay some 1 rupee or so, as it is basically used to check whether you are a valid user or not. Basically you are having a valid credit card details or not. It's basically on that. It's not they are not gonna charge you anything. It's not like that. It's basically a free trial service. They just want to know that whether you are a valid user or not. So what is the scheme of Microsoft Azure? It's similar to the one in by AWS. So the scheme is you will get some free trial services for some 12 months or 8 months. Post free trial services, if you keep on using the services of Microsoft Azure, you will get penalties onto it, and eventually you have to pay for those penalties. But if you do not use after your free trial service, you do not use services of Microsoft Azure, there will be no charges which will be kept on you. Okay, so once you have this Microsoft Azure downloaded, what you need to also do is you need to install Microsoft Azure CLI, which is nothing but command line interface of Microsoft Azure. So if you are in Linux user, go and download for Linux. If you are in Mac OS, go and download for Mac OS. If you are for Windows, then download it from Windows. So the two basic requirements over here are, first you need a Microsoft Azure account, that too verified Microsoft Azure account. Next thing, you require the Microsoft Azure command line interface, and in addition to it, you also require Python. And yes, yeah, because we code everything in Python, so you require Python 3 also. So let's get started with it, how to begin our coding and all. So basically what you need to do is, this is the projects folder where I have initiated my project. This is all my requirements and everything are set over here. So what I need to do is I need to open command line interface or CMD or command prompt here. So when I type in command prompt here, I get the command prompt here, and over here now what I should do is I should start writing this code. Okay, so step by step I will do. So first let me check the Python version what I'm having. Python -3 version. It's saying that Python 3.9.1 is the current version, and AZ version. Let me see the command line interface version of Microsoft Azure. It is saying that it's 2.29. Okay, now what you need to do is you need to type, this is the very important command, az login. So this is nothing but it will authorize your login information. So when you type in az login, you will get a window typed here. Then you have to sign in into your Microsoft Azure account. So once your Microsoft Azure account is created successfully and you sign in, you'll get a message on the tab like it's login successfully, right? So you'll be redirected to this command line interface where you can download this and all this thing. So over here also we can see that the cloud name is Azure Cloud, and name and everything has been given here. So next what we have to do is we need to as the entire project is in projects folder, I have not hosted in the GitHub. I have not hosted yet my code on GitHub. I have just kept it in my local machine. So I need not use this git clone command. Okay, just be very careful. Need not use this git clone command because I have not cloned the repository from GitHub. It's already present in my local machine. So I would not use git clone command here. Now what I need to do is I need to create a Python environment here. Where I have to create the Python environment is very important. Now you see here MLAI is the main directory. Inside that directory projects is there. So over here I have to create my virtual environment. So I am inside MLAI, so I need to go to projects directory, projects folder basically. So what I'll type is cd projects. Just type that and then I am into my projects directory. Okay, the projects directory is the directory where the entire code is there. Okay, where the entire code is there basically. In projects directory the entire code is there. Now what I need to do is I need to type in this virtual environment command, python -3 -m venv space .venv. If you type in, a virtual environment will be created inside projects folder. Once this is completed, I'll show you how it looks like. Then we have to basically activate the virtual environment. Okay, so over here if you see, we get this .venv thing, right? So if you right click here, we have the scripts over here, the Python scripts, then lib, site packages, then include, we have everything over here, right? So now what we have to do is we need to activate this virtual environment. So how to activate it? Just type in, it's a shortcut over here, just type .ve and then press tab, it will autocomplete. Okay, then slash, then press S, then tab, it will autocomplete. Scripts \a tab, activate. Just hit enter. So when you get this kind of command, means when you get this kind of status over here, that means your virtual environment is activated now. Now what you need to do is, in your virtual environment you do not have all the dependencies. Basically in your local system you downloaded Python, you downloaded Flask, you downloaded everything, but in the virtual environment it is not downloaded. Virtual environment means what? Basically you are creating your own environment where you will install what all dependencies you need on part of you. Okay, so in entire environment you will be having, in your entire software you will be having so many things, like you will be having Java, C++, C compiler, Java compiler, C++ compiler, Python interpreter, and so many things. But in your virtual environment you need specifically Python. Okay, you do not require any Java environment or anything. You will work only on Python. So Java, C++ and C code or anything will not affect or will not work in your Python virtual environment. So that is the reason why we did py -3, that is Python 3, that is create virtual environment of Python 3. Okay, so now you are inside your virtual environment. Your virtual environment has been activated. Now you need to install all the dependencies. So just type in pip install minus r. Don't forget minus r, because sometimes what happens is pip always gets updated, so it will just type you it will show an error like upgrade the pip version from 20.0.1 to 20.0. Some reason it will give. So basically you type in minus r so that no such errors comes. So just type in requirements.txt. okay, just type this and press enter. Now it will install all the requirements which you mentioned in this requirements.txt file. So in the requirements.txt file, what all requirements you mentioned, all these requirements will be installed in this virtual environment. Okay, once this is done, what you need to do is you need to make sure that all these requirements are readily running in your local system first. So the entire idea of virtual environment, I'll explain you once again. So what the entire idea of virtual environment is, in a gist I'll be saying you what it means. Okay, till that time I'll say you what it means. So basically virtual environment means what? So let's say that this is your software. Okay, this is your software. Forget about this. So in this you have Java, you have Java, you have JavaScript, you have C++, you have Python, you have C, you have Ruby, and so many languages you are having, XYZ languages you are having in this software. So this is a collection of everything, right? Now you need specifically Python only, you need specifically Java only. Okay, so you need specifically Python, you need specifically JavaScript, you need specifically Java. So for that what we do is in this entire system we will make a virtual environment which occupies almost like 1/5 of the total space of this, for assumption that our packages will take 1/5 of the total space of this. Now this virtual environment will only run on basis of either Python, if you specify py3 - which we specified over here. See, this command is there, no, py-3 -m vnb dot. So what does this mean is, this is the virtual environment of Python. If you want the virtual environment of Java, you should write Java. If you want virtual environment of C++, so you write C++. If you want for C, you write C. JavaScript, you write JavaScript, like that. So virtual environments allow you to install the dependencies whichever are required only, not everything. Okay, it will not allow all the requirements to be installed. Only those requirements are installed in the virtual environment which are specified. So that is why we mentioned this requirements.txt file. So based on this txt file only, this txt file will say that these all the requirements are needed for our Python script to run. Okay, so that is the advantage of using virtual environments, and virtual environments will work always very in a good fashion. Yeah. So now once my everything is installed, like all the packages are installed, as I said that first I will check in my local machine if it's running well or not. So just hit flask run. Now when I hit on flask run, I'll get some URL, localhost URL. So if it's working fine on my local machine, then I will go and deploy this on Microsoft Azure using this AZ Web UP name. Okay, till then let me just check whether this is working fine or not. Okay, just a minute, I'll just check this. Control C, Control V. Yeah, it is working fine. Now if I just enter some values over here, some random values, and let me check whether this is working or not. Yes, it is working absolutely fine. So on my local system this is working absolutely fine. To exit this, you press in Control C. So over here you press in Control C, it will exit. Now is the final step. You need to deploy your machine. You need to deploy this Flask app on Microsoft Azure Cloud. So for that, type in AZ web app up -SKU, whatever the command I have just given there. Just type in that command --name, and over here app name you have to be you have to give your own app name. Okay, so I'm giving campus placement predictor as the name of the app. Okay, now this is my name of the app. Now I will hit enter. Now the disadvantage of Microsoft Azure is this will take a lot of time in deployment. Basically it will take around 10 to 15 minutes as compared to, if you compare Microsoft Azure cloud services with Amazon cloud services or Heroku, the time taken for deployment is very less, but in Microsoft Azure it is more. So this is the disadvantage of Microsoft Azure, that it is very slow. whereas as compared to other platforms. So this was all about the commands. So this command file will be shared with you again. This is very important file. Don't lose this. If you are using Microsoft Azure, always you make sure that you are using command line interface only. If you are using command line interface, then you will not face any problem. Trust me, you will not face any problem if you are using command line interface for any cloud deployment service, whether it's Heroku, whether it's Microsoft Azure, whether it's Amazon, whether it's Google Cloud. You will never face any issues with command line interface. Just make sure that. Okay, so this requirements and this file will be shared. Till then, I'll be waiting for this to get deployed. Once it's deployed, I'll open up and I'll say the advantages and disadvantages of using Microsoft Azure. Till then, do practice the code and do practice these commands. Thank you. Hi. So in the last video, we completed the deployment phase. We executed all these commands line by line, and then then I concluded the video by saying that this will take a little bit time, and it took me like 10 minutes or so for deployment. 7 to 10 minutes it obviously takes, and then after that you'll get this URL over here. So just copy this URL, and you can just click it, you can just open it up in your browser, and then you can work with you can play with the form now. So I'll just randomly type in some values in order to check whether it is really working or not. So if I hit on predict, yes, it's working fine. If I go back and if I plug in some other numbers over here, let's say that I plug in this and hit enter, yep, it's working fine. It's working totally fine. So there is no issue on the deployment side from Microsoft Azure people, and I think so this is all about the project. And the only disadvantage of using Microsoft Azure is that Microsoft Azure is little bit slow. Not little bit, it's very slow as compared to other cloud services. In case of machine learning deployment or whatever, the like full stack data science projects, if you want to deploy it on Microsoft Azure, it takes a little bit time for deploying it. Otherwise it's very otherwise it's user friendly. There are less number of steps which you have to use, just 2 to 3 commands, and then it's all about just waiting for the deployment process. So that was all about from my side, and this deployment script or this deployment readme file will be shared and you can access this, and simultaneously you can practice on the commands. And till then, do practice a lot on full stack data science projects, and do host your projects on Microsoft Azure, Amazon, and many other cloud services, so that you can gain a lot of knowledge out of it. Thank you.